All right, this is going to cover the lesson 3 task. There are 11 questions and the ready for more, which is actually just a couple of questions, which is really easy. So this is going to be a bit lengthy, but I'm going to try and get through this as quick as I can. Question number 1, and if you need to pause, do so, which I would suggest it. Freddie loves fried food. His passion is for the perfect fried food recipes. Led him to opening his restaurant, Fried Freddy's. His two main dishes are fish and chicken. Knowing he also had to open up his menu to people who prefer to have their food grilled instead of fried, how thoughtful of him, he created the following menu board. Fried Freddy's, choose chicken or fish, choose your preference, grilled or fried. After being open for 6 months, Freddie realized he was having more food waste than he should because he was not predicting how much fish and chicken he should use to prepare in advance. Something you want to do if you open up your own business, no matter whether it's food or just clothing items. You buy a bunch of clothing items that don't sell, that doesn't make sense. It's a waste of money. Cuts into your profits. His business friend Tyrell said he could help. What information do you think Tyrell would need? Okay, so you need to answer that question. What do you think his information is? Go ahead and pause it a second. Think about what he would need, and then come back and we'll continue with question number 2. If you came back and said the amount of meals that were sold per day, you'd be right. We need some information on what was sold per day. All right. Question number 2 deals with this. Luckily, Freddie uses his computer to take orders each day, so Tyrell has lots of data to pull from. After determining the average number of customers Freddie serves each day, Tyrell created the following Venn diagram to show Freddie the food preferences of his customers. How is this Venn diagram different from the one you made in the previous lesson? Okay, what do you notice about this one versus in the previous lesson? What it's asking is you should know is this one uses or is using percentages. Okay, whereas the other ones we were using actual numbers. All right? This diagram is showing probabilities, not numbers. All right? So the more we think about the Venn diagram, tells us about his business. Freddie computed the following probabilities. So now we're going to get to questions 3 through 6. All right? And I just need to move this up just a tick so you can see it. There we go. All right, it says question number 3, what is the probability that a randomly selected customer would order fish? All right, so it wants to know the probability of fish. Now, what you're going to have to do for all of these, you can see I've already done it with 4, but it just has a blank Venn diagram. So you need to go ahead and put in fish and put in fry. Right? Why they didn't do that for you, I don't know. They should have done that for you with all of them, but they wanted you to fill it in. So we're all going to refer back to the original diagram. Remember, the 20, the 15, and the 30. So what's the probability that we would choose just fish? Fish is in this circle. So what number or numbers are in this? We have the 20 and the 15, right? Excuse me. I got that backwards. Fried and fish. I put fish and fried. Got to make sure we get it right. So fried and fish. Hopefully somebody caught me on that. I caught myself before I did this. So we need fish and fried, so it's going to be these 2. So these 2 would be the 15 and the 30. Now, one thing that's new is we never have colored in a Venn diagram, so how are you going to do that? I'm simply just going to do this. Okay? That's good enough to shade it in. Simple, and I can still see the 15 and the 30. All right? Number 4, what is the probability that a randomly selected customer would order fish? Excuse me, that's 3. Okay, so probability there, we put them together, is 45%. Sorry, I'll go back and answer 3. And then 4, we want fried and fish. This little symbol here means and it even says it next to it. I didn't write it, but it says fried and fish. So I want fried and I want fish. Remember, the whole circle here is all fried, but I want fried and fish, which is this right in here. So that means it's going to be 15%. And I shade in that little section right there. Right? Number 5, what is the probability that the person prefers fried chicken? So fried and fish, okay? We have fried fish. We don't want any in the fish. We want the fried and we want the other. Okay, what is the other? Go back to my original. And if you have to, look at your original Venn diagram. Go back and look at that. All right, that's how we're going to do that. So I want fried and not fish. Well, over here is going to be grilled, so we can't include that. So fried is anything in here, which I believe, double check, is the 20, and that is correct. And I'm going to go ahead and shade in here, not the overlap, because the overlap would be fish, and that's not what I want. Okay, I want fried. Number 6, what is the probability, the estimated probability that a randomly selected customer would order fish and want it grilled? Okay, so now we want fish and we want it grilled. Well, fish in here is fried. Okay, so anything else outside the fried circle is grilled. Okay, but I want fish and grilled. I don't want chicken and grilled. So that's going to be in here, which should be the 30%, I believe, right here. I didn't put the line in there. And so all I'm going to do is shade here, and again, not the overlap. I don't want to shade the overlap. All right. Question 7. Okay, we got a few more of these to do, and then we'll be finished here with this. 7. What is the probability that a randomly selected person would choose fish or something fried? Okay, that's fish. Fish is all here, or something fried. Well, this little overlap is also fried. So there's fish, there's fried, right? What are those numbers? Those numbers are going to be 20, 15, and 30. And if we add those up, we should get 60, it's going to be 65%. Number 8, what's the probability that a randomly selected person would not choose fish or fried? If we're not going to choose fish or fried, we're not choosing anything in the circle. Nothing in the overlap, but we have to choose something on the Venn diagram. Well, if we're not choosing fried and we're not choosing fish, we're choosing grilled and chicken. So what is grilled and chicken? Grilled and chicken, this number down here from our original would be 35. And you're going, well, gee, what do we shade? We shade everywhere but not in the circles. That's where we shade. Everywhere but not in the circles. All right? And then number 9. So this just gives you a little taste on how we shade Venn diagrams. If Freddie serves 100 meals for lunch on a particular day, how many orders of fish would he have to prepare with his famous fried recipe? So I want fish and fried. Go back to our original over here. We're going to do a little mobile cam here. So fish and fried. I want fish and fried. Now these are percentages. So this is out of per 100. So what you should read is that overlap in the middle there, which is 15. So we're going to say he needs to fix approximately, the little A with the circle, about 15 meals. That's what he would need to fix. Okay? And then 10, it says, just as Freddie hoped, messing around with diagrams makes him think he discovered a relationship. Here's the theory. So what's the probability of fried or fish? Well, that's a probability of fish, which, again, go back to your original. What's your probability of fish? Fish is 15 and 30, which is 45. Plus your probability, and I'll actually do this, which is 30 plus 15. Plus your probability of fried. Your probability of fried is 20 plus 15. And it says minus fish and fried. Well, notice, and if I just put up 45 and I just put up 35, you wouldn't see this. But because I put 30 and 15 and 20 and 15, you can see that I double counted. I double counted the 15, the overlap. In statistics, you cannot do that. So we have to subtract one of these 15s. So we get 45 plus 35 minus the 15, and what does that give me? That gives me a total of 65%, right? It makes a little bit more sense when we look at a two-way table, but you cannot double count. So what's the probability of fried or fish? The probability of fried or fish, again, we look at the probability of fish, we look at the probability of fried and we subtract the probability of fried and fish, the overlap. So here's where they're getting into a little addition and subtraction. And then lastly, you're looking at question number 11, which is the probability of A or B. Well, gee, how am I going to fill out a Venn diagram that way? It's the probability of A, so I'm just going to put A here and B here. That's those circles, probability of A or B. How do we figure that out? Well, the probability of A, right, and I've got to include that overlap because A is in the overlap. Now the probability of B, and notice I'm going in a different direction. And what does this in the middle here represent? What does it represent? Go back to 10. This is the probability of A and, that's a horrible and B right there. All right, that's what that would represent. So you can see that. And then the ready for more. I'm going to do the ready for more here real quick. And I know this is taking longer than I thought, but we have question number 10. Excuse me, ready for more. We have A, and then we have B. So write a statement about the addition rule for P prefers chocolate or 10th grade. Well, gee, that's going to be the probability of chocolate, okay, plus the probability of 10th grade right here, minus the probability of chocolate and 10th. So how am I going to do this? Well, it says there's your probability right there. It says write the statement of the addition rule. So here's the statement of your addition rule, and then now it says use the two-way table to show this is true. Well, what's the probability of chocolate? If you use the two-way table, the probability of chocolate is 29 out of 47 minus what's the probability of 10th? Okay, would be 14 out of 47. But if you notice, we counted a couple of things twice. Okay, so probability of chocolate, probability of 10th. What did we count twice? We counted 6 twice. That's a plus, not a minus. So since we counted the 6 twice, we have to subtract the 6 once. And notice all these have a common denominator, so we can go ahead and write over 47. 29 plus 14 minus 6 is going to be 37. There's your total. That's your probability. So just to give you a heads up of how we create that number, and then this is the number we would turn into a decimal and a percent. Right? There's your notes for today.